All right, hello everyone. Welcome to our first class, which I thought would be on a Google Meet, and now it has turned out that it's going to be on a video, but that's okay. If there's one thing that this whole year has taught me, it's to be flexible and be able to adapt, and so that's what we're doing right now. Okay, so I am Mrs. Mullert. I am a teacher at Oak Ridge High School. So next year I'll have Algebra 2 and AP Calculus and Advanced Pre-Calculus, so I won't be seeing any of you because we're trying to get you guys into geometry. But I have taught geometry for years, so I kind of know what you need to know to get there. So that's why I've put together this course to help you guys. So this course is 8 days. So you are going to be on a meet, hopefully, from 3 to 4 for the next 8 days. And then on the 9th day, which will be next Friday, you'll come into my classroom from 3 to 5 and take that challenge exam. And if you pass the challenge exam with an 80% or better, you can be placed in geometry next year instead of Algebra 1. So who should be in this class? It should be students, obviously, 8th graders, or incoming freshmen, and you should have been in Algebra 1, but your teacher perhaps didn't recommend you for geometry, so you want to challenge that by getting this little refresher here. Or you were in Math 8 with a really strong grade, and you want to, you have a good understanding of math, and you have strong skills, and you're technically trying to sort of skip Algebra 1, which is a big feat because Algebra 1 is hugely important. So you want to make sure that you're a good fit if you're coming out of Math 8, that you're really strong and you had a 90% or above, and you feel like you could grasp concepts really quickly. This class is not a replacement for Algebra 1. This is 8 days. That is obviously not a replacement for a whole full year course. So I just want to make sure, we understand that this is just a boost for the test, but not a replacement of Algebra 1. It's going to allow you to kind of skip Algebra 1 if you're in that Math 8, but please don't consider the full content to be a full Algebra 1 course. It's just simply not possible because, it's 8 days versus a whole school year. Okay, so with that being said, I'm going to be every day just here going over topics, and there are 22 skills here. I think in the exam they're letters, so it's A through V, and here I've got them, 1 through 22. So you'll see, you should have printed out this note packet from Google Classroom, and so I'm going to go through sample problems and then assign the remaining ones for homework. And when I say homework, it's really just practice for you because we only have an hour, so I don't have a lot of time to go over homework with you guys. I will be able to answer questions at the end of meets if we have leftover time. Otherwise, you want to check this against the key that I have posted in Google Classroom. So make sure on the stream at the very bottom where you found the note packet that you check your problems against the key to make sure and I showed all the work so that you can see what you've done well or what you've done wrong, and you can learn from that. A lot of this is going to require you to be self-motivated and be a self-starter, and if you're really confused on a topic, watch a video. I put a link to my favorite videos, which is Patrick JMT, in the stream as well. So if you have problems, say, solving a linear equation, you could look through his videos and try to find that. My only time here is, right at this 3 to 4. There's not a lot of availability for me outside of this allotted time that the district has given me to do this. They've given me this 1 hour to do this. So a lot of this, if you have questions, is going to take some self-motivation on your part to go out there and find the instruction that you need from videos. But I will do my best. I'll do my very best to get you guys through this. So with that being said, let's get started on skill number 1, or letter A, I think, in the challenge exam. So we're going to solve an equation. I mean, that is the point of math, is try to solve an equation, solve for an unknown here, so a variable. So D is not known, so, what is D? We're going to just walk over here and isolate D. So we've got three different kind of examples of a pretty easy linear one with a fraction, and then one with some distributive property going on here. And then you'll see that there's more of, a kind of a similar linear, a similar fraction, and then one with the distributive property. Okay, and so these will be the ones that you're going to want to practice. Okay, so here we go. Welcome to our course. Skill number 1, solve an equation. Okay, so the ultimate goal is to get D equal. Okay, so let's just think about that for a minute. What's being asked of us here is to find D. So the last step is, we want to get D equal. All right, so if we look here, we want to isolate. I'm going to use that word, isolate. We want to isolate D. So we're going to go and collect like terms. So when you have a linear, now how do I know this is linear? I know this is linear because this is D to the first power and D to the first power. When we get to the quadratics later on, they're going to have a power of 2. And you solve those a little bit differently. So this is a linear. Skill number 1, these are linear. And what you want to have go through your mind is collect like terms and isolate the variable. Okay, so I'm going to collect like terms, and the like terms here would be 3D and, this negative 5D are like terms, okay, because they have a D. These are just constants, negative 7 and 9, whereas the D and the negative 5, the 3D and the negative 5D are like terms. So what you've seen, before probably is when you collect like terms is you've probably gone plus 5D, plus 5D, draw a line. When you add 5D to negative 5D, those cross out. 5D plus 8D, and then you bring the rest down. And then we're going to add 7, and we're going to cross that out. Over 8D is equal to 16. Divide by the 8, so on and so forth. Okay, and so that's great, but what we're going to do instead, just to make things a little bit cleaner and move a little bit more quickly, is we're going to think about collecting the like terms. We're going to get our variables on the left and our constants on the right. And I'm just going to think about this 5D right here, which is negative. All right, 3D is on the left, and I'm going to think about negative 5D crossing to the other side, so going from the right side to the left side, and it's almost as if this equal sign zaps the sign. This negative becomes a positive, and we're just going to move it, pick it up and move it to the other side. And similarly with the negative 7, I'm going to pick it up and move it to the other side, and it becomes plus 7. So I've collected like terms. With variable terms on the left and constants on the right. All right, so 3D plus 5D is 8D, and that's equal to 16. 9 plus 7 is 16. And then what we're going to do is divide by this 8. So we undo, we negate this negative 7 by a plus 7, but when we're being multiplied here, to isolate D, we're going to cross out that 8. And if you do to the left, this divide by 8 on the left, we have to do that to the right as well. And this is D is equal to 2. So we got to our goal of D equal by moving terms from side to side and then dividing by this 8 to isolate the D fully to this 2. The good news with any of these is if you have time is you can always check them. When you get to D equals to 2, you can always check your work. 3 times 2 minus 7 equals 9 minus 5 times 2. So if you are here and you just plug in this 2 right here for this D, just plug that back in, we get 6 minus 7 equals 9 minus 10. Okay, 3 times 2 is 6, minus 7, and then 9. 5 times 2 is 10, and we see that that is positive 6 and negative 7, so that's a negative 1. And 9 and then minus 10 is a negative 1, and so it checks. So I can leave this problem knowing 100% that I got it correct. Since it checks, I can have confidence that I got this problem perfectly solved. Okay, so the next one is solve for b. Now we have some fractions here. So again, think about your terms. That is a term, and that's a term. So I want those on the left. This is a positive. There's no positive sign here, but it's an understood positive, so it becomes a negative. And then this is a negative 4, and then this positive 3 goes to the other side as a negative 3. All right, so here's our fractions. Fractions are going to require a lowest common denominator. So we're going to have to adjust this 3/4 b and this 2/3 b to have a common denominator. So we want the lowest thing that both 4 and 3 will divide into. You guys are probably thinking 12, and you are correct. So we're going to just adjust. We're going to adjust. And if you want to go ahead and put this together, you can. It's -7. That's 4 negatives and 3 negatives. So when you're adding and subtracting, you kind of collect the signs here. So 4 negatives and 3 negatives, that makes 7 negatives there. So it's -7. All right, so let's go back to our fraction word here. So 4 went to 12. So how did 4 change to 12? Well, it was 4 times 3 was 12. So basically 4 goes into 12 3 times. It was multiplied by 3, so you have to do the same thing to this 3 here, and that's 9. So basically, just 4 goes into 12 3 times, so that 3 also hits the 3 in the numerator, and you get 9/12 b. All right? 3 times, what is 12? That's 4, or you could think 3 goes into 12 4 times. 4 then times the 2 there is 8. Okay, so now that we have common denominators, we can put these guys together. So 9b, 9/12 b minus 8/12 b. Once you go to the trouble of getting the common denominator, it stays, and so you just work in the numerator. So basically, you leave the 12, and then you say 9/12 minus 8/12, and you just do 9 minus 8. All right, so 9 minus 8 is 1/12. b equals -7. Some people prefer to write that as b/12 equals -7. Either way, it does not matter. This means the same. And that means the same thing. Okay, and so now we've got b divided by 12. Remember, my goal is to get b equals. My goal is to get b equals. So b has been divided by 12, so to kind of battle that division by 12, I'm going to multiply both sides by 12. And when you get 12/12, that's just 1, and so that just cancels out to 1b, which is what really this is when you have b equals. That's 1b, and then we do -7 times 12, which is -84. Okay, and this 1, we do not need to write that, so I'm just going to use that as part of my box. Okay, moving right along, our third one in solving. Hopefully you've seen this. I mean, this is stuff you've probably even seen earlier than Math 8, so hopefully at this point you're like, okay, yeah, this rings a bell, this looks good. The next one is going to involve the distributive property. And so basically, you guys, on the challenge test, you'll have one that's linear, you'll have one with a fraction, and you'll have one with a distributive property. So with my prep here, I'm being pretty transparent about what the test looks like for you guys. Okay, so the distributive property says 3 times parentheses equals 41 minus 3 times parentheses. So I'm not even going to worry about 2c plus 1 or c minus 5. I'm just going to say the word parentheses. So 3 times equals 41, and then minus 3 times. So with the order of operations, I've got to do the times first. I have to do the times first. So why am I saying this? Is I do not want you to go like this. Oh, that's a 38. That is going against the order of operation. That's a huge mistake that students make. Huge mistake students make. And so I don't want you guys to do that. So I'm going to erase that with my handy dandy erasable pen. And we're going to follow the operations and do our multiplication first. So this just says multiply 3 with everything in parentheses. Multiply 3 with parentheses, so you multiply 3 with everything in parentheses. So I'm going to actually go over here to give myself some room. So 3 gets multiplied with 2c, which is 6c. 3 times 2 is 6. and 3 gets multiplied with 1, which is plus 3. 41 is going to have to wait its turn because of the order of operations. It's going to have to just sit there and wait its turn, and I'm going to be multiplying this negative 3 here. Okay, so this is minus this 3 times this. You could write the minus sign and then do 3c and that negative 15, but then you would have to keep that in parentheses, and you're going to probably miss a sign there. So it's easier just to think about this as a negative 3 being distributed to the parenthesis, and then you'll have a less of a chance of missing a sign there. So negative 3 times c is negative 3c. And then negative 3 times negative 5. A negative times a negative is a positive, okay? So this was a negative times a positive, which was a negative, and this is a negative times a negative, which is a positive 15. And then with that step, guess where we are? We're right back here to the easy type. With that distribution, we're right back here with easy type. So just be really careful on this part. Be careful not to make that a 38, that you're going out of the order of operations. And then make sure when you distribute, you carry that negative with your distribution and follow your rules for multiplying with positives and negatives, and you'll be all set. Okay, so again, 6c, pick this up. You grab the sign in front of a turn. I just imagine picking it up and moving it to the other side, and it gets zapped by this equality sign. I mean, really what's happening is you're adding 3c and adding 3c, but that gets, your work can be kind of lengthy and messy there when you go that. And we've kind of graduated past that once you get to high school. So 41 plus 15, and then this plus 3 is going to go to the other side. It's negative 3. It's just a game. Math is just a game of what to do and, when to do it. All right? And then I have 41 plus 15 minus 3. So you can just tally those up. You're going to have a calculator on the exam. So, don't stress about this little showing your work over here with the arithmetic. We're just going to add these all up, all right? And we're going to get that to equal 53. And so 9 times c equals 53. So 9 times c, there's an understood times right there. That's a little, if you don't see anything there, that's times. 9 times c is 53. So we negate to isolate by divide both sides by 9, divide both sides by 9, and our answer here is c is 53 over 9. All right, so that is skill 1, you guys. You have 6 problems to try on your own and to check your key. Okay? And if you have any crazy questions on them, I will happy to help you at the end of the meet tomorrow. Otherwise, the only other thing is I did this key all by myself, so I may have made some typos along the way or some mistakes. So there might be some misprints on my key. I tried to check out really carefully, but nobody's perfect. So there may be, just ask, somebody else if they got what you got, and more than likely the chances are that you guys will be right. All right, topic number 2, proportional reasoning and solving a proportion. So some of these are word problems and some of these are equations. So you will see these on the challenge exam as well. So proportional reasoning. So what is a proportion? All right, so a proportion is where you're going to compare two ratios. So a proportion is a comparison of two ratios. So AB equals CD. A proportion compares two ratios. Okay, so this is a ratio. A ratio is just a fraction. A ratio is just really a ratio is a comparison of two numbers, and a proportion is, maybe we could even say, an equation of two ratios. Okay, so a ratio is comparing these two numbers, and then the proportion is setting up an equation of these two comparisons. So, all right, so let's look at the problem here. Matt is studying for a factoring test in his algebra class. He finds that he can accurately factor 3 problems every 7 minutes. At this rate, how long will it take him to factor the 40 problems on the review? Round your answer to the nearest minute. All right, so nearest minute. Okay, so all you want to do is write your two ratios, and you just want to be organized in how you write them. As long as you stay organized, you don't have to really stress too hard about who's the numerator and who's the denominator, as long as you're organized. Okay, so Matt is studying for a factoring test in his algebra class. I always read the problem first and then go back and read it sentence by sentence. Okay, so he's studying for a factoring test. That's not really anything math for us, right? That's just giving you the scenario. He finds that he can accurately factor 3 problems every 7 minutes. Okay, so he can do 3 problems every 7 minutes. 3 problems every 7 minutes. So you can put your nouns there to keep yourself organized. So what did we do? We just compared two things. A ratio compares 2 things. It compared problems with minutes. And so the proportion is going to kind of equate those 2 ratios. All right, at this rate, how long will it take him to factor the 40 problems in the review? All right, so how long, there's the question. There's the question. So that's how you know that's where your variable goes. Okay, so how long, so the variable is going to go, and long is time. So it's a question of time. This is a question of time. So I want to put my x down here, and then so how long will it take him to factor the 40 problems? So I want to put 40 with problems. I want to put 40 in the numerator because I'm putting problems numerator and minutes in the denominator. And that's it. There's your proportion. We've just compared two, we've just equalized 2 comparisons of two items, problems and minutes. All right, so how do we solve proportions? We solve proportions as long as it's a simple fraction equal to another simple fraction. We solve these by what we call cross multiplying. All right, so you're just going to go A times D equals B times C. You're just going to cross multiply. All right, so what you're really doing is multiplying this side by D and this side by D, and that crosses out the D's, and you're multiplying this side by B and this side by B, and that crosses out the B's, and you get CB. So it looks like, the cross multiplication is kind of a shortcut to this. If I were to do D here and D here, that would go, right? And so then you've got dA over B equals C, and then times B and times B, and you can see we get AD equals BC if you just kind of rearrange those, which is the same thing. So cross multiplication is just a shortcut to the proper algebra that's here. All right, so I just wanted to kind of show that so it's not just something made up that magically works. Okay. All right, so we're going to cross multiply. So we're just going to say x times 3, and I'm going to write 3x. I'm going to write the 3 first because that's customary, and then 7 times 40 or 40 times 7, it doesn't matter because multiplication is commutative. You're going to get the same result whoever you write first. That's 280. And then last step is usually divide out that 3, divide out that 3. You have your calculator, and this is 93.333 minutes. That 93 repeats. But they've asked to the nearest minute, so they just want to say 93 minutes. 93 minutes there. Okay, so once you get the hang of these, they begin to flow pretty quickly, I think. Okay, so a rectangle has a length of 4.5 centimeters and a width of 3.2 centimeters. A similar rectangle has a length of 15 centimeters. What is the width of the other rectangle? Round your answers to the nearest tenth. All right, so again, we're just going to do the same thing. Length is 4.5. Width is 3.2. All right, similar has a length of 15. Be organized. And what is the width? There's your question, so there goes in your variable. So as long as everybody's in the same organized place, the cross multiplication will work itself out. Okay, so 4.5x equals 3.2 times 15. Sometimes when numbers are, just numbers times numbers, I'll use a parenthesis versus a dot so that you don't get confused later on of what's the operation that is going on. Okay, you've got your calculator. Again, when I write these numbers, I'm just simply taking my calculator here and going 3.2 times 15, and we get 48. And then we divide by 4.5, divide by 4.5, and we get 10.6 repeating. Okay, and look at our units. Our units are important here. Those are centimeters, so we want to put our centimeters there. And then also look back and the last directions round your answer to the nearest tenth. Okay, so the 10th place is right here. And so we're going to round that, since 6 is bigger than 5. We're going to round that up to 10.7 centimeters. Okay, so there's proportional reasoning with word problems. So I've got 1, 2, 3, 4 for you to try there, and then check your work on my key. Okay, so let's do solving a proportion with equations. So these are actually, some people find these a little easier because you don't have to decipher the word problem. So you'll have to do some of these on the exam. And we just cross multiply. Proportions you solve with cross multiplying. All right, so when you read that word proportion, think cross multiplying. All right, so we're going to cross multiply. So I'm going to do 5 times x plus 3. Okay, so grouping symbols. Grouping symbols are parentheses, brackets, braces. Guess what else is a grouping symbol? A fraction bar. Okay, a fraction bar is a grouping symbol. So this may as well be in parentheses. That fraction bar groups it. So you want to use those parentheses, or you're going to miss the distribution here of the 5. I'll show you what I mean. So when I go here, 5 parentheses x plus 3 equals 12 times x. Okay, so if you don't put those parentheses here, you're going to have 5x plus 3 equals 12x, and that's the problem. So you want to put that in parentheses so that then you're prompted to do the distributive property, because this says to you 5 times everything in parentheses. So 5 times x plus 5 times 3 is 15, and we get 12x here on the other side. So 5x plus 15 equals 12x, and we're just going to divide out, we're going to collect like terms. So we're going to get 5x and 12x. The 12x becomes minus 12x, and then the 15 over to the right is negative 15, and so we get negative 7x, right? That's 5 positives and 12 negatives. Positive 5x minus 12x, so I've got some positives and some negatives. Who do I have more of? I have more negatives by how many? 7, so it's negative 7x, and then equals negative 15. Divide out by negative 7, divide out by negative 7, and a negative divided by a negative is a positive. So you have to switch your brain, your sign rules when you're adding or subtracting, or your sign rules when you're multiplying and dividing. All right. So here we go. Let's try this one. So cross multiplying 3 times 3y plus 1, put it in parentheses. And then I'm going to put the 4, we'll cross multiply kind of this way, and this way, because I want the 4 in front. Doesn't matter. Multiplication is commutative. It moves. You could say 3 times 5 is 15, or 5 times 3 is 15. It doesn't matter. All right. And so distribute. 9y plus 3 equals 4y minus 8. That's 9y and 3 and 4y minus 8. All right, so those are my like terms there. Excuse me. 9y, the 4y comes over to the left is negative 4y. Negative 8 is over here, and the positive 3 goes over to the other side. It's negative 3. 5y equals, that's a negative, so negative 8, and then negative 3 is a total of 11 negatives. Okay, so 5y is equal to negative 11. Divide by 5, divide by 5. Y is equal to a negative 11 over 5 right there. Okay, so that was positive 9 and negative 4y, so that's 9 positives and 4 negatives, so that's more positives by 5. But these are all negatives, so you just add them all up for negative 11. Okay, let's try one more where we have some negatives to multiply here, and then we'll move on to our last skill. All right, so 5 times parentheses, parentheses, parentheses. I like to say that parentheses are your best friend in mathematics. Parentheses can help you keep yourself straight. Okay, so 5 times 2x minus 3, and then let's multiply these. And a negative times a negative is a positive. Okay, when you're multiplying with negatives, negative times a negative is a positive. So negative 3 times negative 5x. That's going to be a positive. So distribute 10x, distribute a negative 15, and then negative times a negative. We're multiplying here, not tallying up. We're multiplying, so that's positive 15x. All right, so 10x and 15x, and then 15 goes to the other side is positive 15. This is negative 5x equals 15. Divide by negative 5, divide by negative 5. All right, so those cancel. We've isolated x, always trying to get it down to x equals. And then I have got 15 divided by negative 5. A positive divided by a negative is a negative, and this is negative 3. Okay, so the next 3 for you guys to try on your own and practice so you can successfully solve these types of problems on your challenge exam. Okay. Last part here is the Pythagorean theorem. All right. So Pythagorean theorem comes in a bunch in geometry all the time. And so hopefully you've seen something like this before. If not, don't worry. Yeah. So we're going to use the Pythagorean theorem. We have a right triangle. And so with the right triangle, you can apply what's called the Pythagorean theorem. All right, so the Pythagorean theorem says in every single right triangle in the whole world, you can compare the legs, or I should say the sides of the triangle. So first thing you want to realize is if it's a right triangle, you have a 90-degree angle. Okay, a right triangle has a 90-degree angle, a perfect L shape. Okay, and so across from the 90-degree angle, you have a side. Okay, this is this is a side of the triangle, but this has a special name. It's called the hypotenuse. And it's going to be the longest side. It's going to be the longest side. Why is it the longest side? Because it's going to be across from the largest angle. All of the angles in a triangle add up to 180, and so if one of them is 90, the other two together have to be 90. So each one of them alone has to be less than 90. So the hypotenuse is always going to be the longest side because it's across from the longest angle. I mean, if the angle is wider, the angle is the longer the side. And so the hypotenuse is always the longest side. It's always across from the 90-degree angle. And A and B, we just call these legs. They don't really have a name. They're just the two legs that have their they're kind of adjacent to each other or connected by that 90 degrees. So the Pythagorean theorem says in every single right triangle, if you take leg number 1 and square it, and leg number 2 and square it, it will equal the hypotenuse squared. And there's a fun proof about this that you can watch. Sometimes we go through the proof in geometry if we have time, but for now we're just going to, accept that this is true, and, that's your Pythagorean theorem. A squared plus b squared equals c squared. Only works for right triangles. You got to make sure that the hypotenuse is, on the right side or on the side by itself. And you want to make sure you square them and add them and all that good stuff. So here on the child's exam, you're going to have to solve for some of these right triangles. And so here's just, lots of different scenarios. So just write your formula down. Write your Pythagorean theorem down. A is 3, so 3 squared. B is 4, so 4 squared. And c squared is just c squared. All right, and so we're going to solve this equation. So 3 times 3, 3 squared means 3 times 3. 4 squared means 4 times 4. C squared equals c squared. So that's an exponent of 2, and that just means that 3 is multiplied by itself 2 times. Not 3 times 2, but 3 is multiplied by itself twice. So 3 times 3. 4 squared, 4 times 4, so on and so forth. Okay, so this is 9 plus 16 equals c squared. 25 equals c squared. All right, so something squared equals 25. We want to, always are trying to isolate. We always want c alone, and I've got c on the right side. That's fine. You can switch it if you like, but it's okay to solve if your variable's on the right. And so when we are trying to negate addition, we subtract. When we're trying to negate multiplication, we divide. When we're trying to when we need to break the c away from it being squared, and so the kind of the inverse operation of squaring is square rooting. So we're going to square root and square root. Okay? So when you're at this step, you're going to square root that c squared. I'll just show that step. And what multiplied by itself twice is 25, and that's going to be 5. All right, and that you can do on your calculators. Second square root of 25, close parentheses, you'll get 5. All right, so not all of these are going to be, perfect like that, but, this is a you see 3, 4, 5 all the time. All the time. We actually call this a Pythagorean triple. Because these, there are no decimals, there are no fractions, they're just these perfect little plump whole numbers here that work. So that's a Pythagorean triple. All right, so let's look at another one here. Here, now notice that we don't know what A is. So always write your formula first because it gives you a plan. Now it's A squared plus 36 squared equals 45 squared. Those are really big numbers. But don't worry, because you have your, you're going to have your calculator that you're using, and so you don't have to, stress about doing the side workout and making a mistake there. All right, so we've got A squared, we've got 36 squared, which is 1296. A squared equals 36 times 96. So you could do 36 times 36 on the calculator. You can't see that. 36 times 36. Or you can do 36 up arrow squared. Or on this TI, I can do 36 and the square button's right there. Doesn't really matter. You get, what was it? 1296. 1296. 1296. Right? And then 45 times 45 is 2025. Okay, so this time I want to subtract this from both sides. So I'm going to scooch A squared over a little bit. 2025 minus 1296. Let's see what A squared is. 2025 minus 1296 is 729. Okay, so is something squared equal to 729? Well, we're going to have our calculator help us here, but we're going to get A isolated by doing the kind of the reverse of squaring is square rooting. You could think of it that way. We're going to square root both sides. That will just kind of like cross each other out, right? They cross each other out, and so we're going to do the square root of 729 here, and that is 27. So this, you guys, is another triple. This is another triple, and so those are just kind of fun to note that they have a special name called the triple. And then if it doesn't come out perfectly, that's fine too. So let's just do this last one here where with A, B, and C. So again, A squared plus B squared. If you write it down first, you're less likely to misplace who goes where. You could even do, you can even go ahead and pick up this 18 square if you like, and just go over here, 32 squared minus 18 squared. B squared equals, okay, so we'll go here and 32 squared is 1024. 18 squared is 324. Okay, and then 1024 minus 324 is 700. And when we go to square root 700, oops, you get a decimal. And so that's fine too. It doesn't have to be a Pythagorean triple. It doesn't have to be a perfect whole number that comes out. It can be a decimal, but when you go to that, you always want to go up to your directions and say, what do they want me to do with this? What do they want me to do with this? Round to the nearest tenth. So B squared equal to 700 is here. B is equal to 26.5. Okay, so that is our first session, our first 3 skills. And so I want you guys to then work through, what did we do? We did this one, 26.5. I want you guys to work through all of these. And I am going to get busy right now and try to figure out how to, it looks like everybody was able to get into Zoom. So I'm going to work on Zoom and try to figure out how you all got in today. So whatever I did today on the fly worked. And figure out how to present my screen and figure out how to use this little document camera that I'm using here, because it's just nice for you to see me on the same exact note packet, I think, working through it. Anyway, so I hope that all made sense, and I will look forward to seeing you guys on some sort of platform tomorrow. Look for an email from me tonight with what we're going to do. Okay? All right. Bye.